So this is a project I'm currently working on. It's a BeagleBone Black embedded Linux computer with a 32-bit ARM chip and assorted other stuff on it. It has a number of general purpose IOs that are currently being used to flash LEDs. And it has a I2C data bus that I've been using to talk to this little board that has 3 degrees of acceleration, 3 degrees of rotation, 3 degrees of magnetic field, and temperature and pressure sensors. So there's a lot of sensors on that little board. Hold my finger up to it and you can see a bit of scale on how big it is. So there's a program running on here that reads the data and sends it out over the network in a broadcast, and then the values are actually displayed up here. So the top row is rotation rates, second row is acceleration, and you can see the z-axis is about 1 g of acceleration. Third row is magnetic field, and the bottom row is temperature, air pressure, and a simulated attitude indicator. The attitude indicator is based on the rotation rates. So as long as the rates are 0, it's not moving. Now if I pick up the board and start moving it around, you can see the gauges start moving as the sensor is actually reading data. And as I level the board out again, you can see that the attitude is a bit off because there's a little bit of noise and stuff in the sensors, and integration to provide the attitude tends to accentuate the noise. With a bit of work that could be reduced, but right now it just kind of gives a handy example of putting a bunch of sensors together and actually collecting data and doing something with it. Now, if it sits for a while, not moving, it will recalibrate the attitude and set it back to whatever the acceleration sensors suggest is straight and level. Yep, there it went. So that's my current project.